Welcome to this tutorial. I am Amok Joshi, a machine learning engineer at Latent AI. Today, we'll explore how to enhance machine learning workflows using LEIP Design's powerful data visualization integration. Traditionally, working with large datasets meant dealing with cumbersome downloads, manual pre-processing, and complex data ingestion workflows. LEIP Design changes the game by making it incredibly simple to visualize, inspect, and refine your datasets directly with FiftyOne, an open source data visualization platform, and then allows you to seamlessly integrate them into your machine learning pipeline. By the end of this session, you will have a clear understanding of how to leverage this integration to simplify your workflow, save time, and ensure your datasets are highly optimized for guaranteed success. Let's dive in. In the first step, we begin by loading our dataset into FiftyOne. In this example, we are using an industrial surface defect detection dataset of the Pascal walk format. Here's the code for loading the dataset into FiftyOne. We start by importing the necessary libraries and then define the path to our dataset. Here, we generate a unique name for our dataset using the current timestamp, specify the data format, and load the dataset using FiftyOne API. We then split the data into training and validation subsets, with 75% of the data allocated to training and 25% for validation. Finally, we launch the FiftyOne web app for visualizing the dataset by specifying the port. Now that we have launched the FiftyOne app, let's explore its interface. In the center, you can navigate through the dataset samples. Each sample displays the image alongside its ground truth annotations, showing bounding boxes with the corresponding labels. You can also use the right panel to view or edit metadata for any selected sample. You will see all 6 classes in our dataset listed on the left panel under Labels section, along with their counts. This panel allows you to filter samples by class or tag easily. Next, for a better understanding of the dataset, let's look at the ground truth annotations for the first sample in our dataset. This will include labels and bounding boxes for each detection. The output lists the labels and the corresponding bounding box coordinates, giving us an overview of the dataset structure and its annotations. In this part of the tutorial, we'll filter the dataset to include only the samples that have detections for specific classes that we care about. This is especially useful when you have a dataset with a wide variety of classes, but you are only interested in a subset of them. First, let's define which classes we want to keep in our dataset. Here, we are interested in detecting 2 classes, inclusion and patches. We create a list and store the names of these 2 classes in it. Now, we'll create a new dataset that will store the filtered samples. We iterate over each sample in the original dataset, filter the detections based on our target classes, and update the sample with the relevant detections. If a sample has no relevant detections, we skip it. Else, we create a copy of the sample, overwrite its detections with the filtered ones, and add it to the new dataset. Now that we have filtered all the samples, let's make sure we keep the train and val subsets as separate views. We use the match tags method to filter samples with the train and val tags and then save them as views. After applying the filtering, let's launch the FiftyOne app again. This time, you'll notice that only samples containing detections for our 2 target classes, inclusion and patches, are visible. See how easy it was to tailor the dataset to your own needs. Now, let's take a closer look at how LEIP Design streamlines this process of integrating a dataset from FiftyOne into your machine learning workflow. This is a critical step that traditionally requires downloading the dataset locally, a process that can be both time consuming and resource intensive. With LEIP Design, this workflow is optimized to be seamless and efficient. We start by importing LEIP Recipe Designer along with some key helper functions. These tools allow us to create and configure an object detection recipe that serves as the foundation for training and deploying machine learning models. First, we define our workspace and pantry paths. Think of the pantry as a central hub that stores all recipe components, ensuring a consistent and modular structure for your workflow. Next, we create an empty recipe specifically for object detection. This step ensures that the recipe is initialized and ready to be populated with all the necessary components for our task. Here's where the magic happens. We attach the filtered dataset from FiftyOne directly as a data generator ingredient to the recipe. This integration eliminates the need for local downloads or manual data management. Instead, the dataset is seamlessly linked to the recipe, making it immediately accessible for training and evaluation. Finally, we replace the recipe's default data generator with the one linked to FiftyOne dataset and fill in any remaining gaps to ensure the recipe is complete and ready to use. This process not only saves time but also ensures that your workflow is both memory efficient and error free. Let's print the data generator ingredient of the recipe to verify that our custom dataset has been successfully ingested. This demonstrates how LEIP Design empowers you to focus on refining your model while the complexities of data ingestion are handled behind the scenes. It's an absolute game changer for building efficient and scalable machine learning pipelines. Congratulations! You have successfully visualized, customized, and ingested your dataset into LEIP in just a few minutes. From here, you can continue your journey by following the steps outlined in the Getting Started tutorial to train, evaluate, optimize, and deploy your model seamlessly. Thank you.